So welcome to today's session, which is the first of 5 for the technical training course on mobile phone data for policy. And it's my pleasure to welcome Egle Rutle, who's working at Positium and who is our instructor for today. She's going to be taking us through the topic of input data and quality assurance, both in terms of a quick summary of the theory and then also a run through on the notebooks that you've all been advised to have a look at for practical purposes. So without further ado, I'll hand over to you. Thank you.
Thank you, Kathy. And hello to everybody from my side as well. And big thanks for you to finding time to participate in today's session. So I will start sharing my screen. As said, I'll start with a quick overview of the theoretical part. And the topic today is input data quality assurance and cleaning. So I think we all here can agree that quality in input data is very important for our work because our goal is to produce the best statistics as we can because we want to give the best input for this decision-making process. So we all know this classic phrase, garbage in, garbage out, meaning if there's any issues with the input data, then the output will also have some issues or it will be also affected. And also quality is a very public trust as well. So now when you start working with mobile phone data, there might be several issues you face. First, let's quickly talk about things you might encounter on a record level. So there might be duplicate rows in the data, there can be missing values, there can be issues with the data types. So basically everything you face when you work with any kind of data, and people joining in today who are like data people day to day, then there's nothing new here for you, I believe. Now, when you start analyzing the data further, you start looking at the spatial and temporal patterns, then more things appear from the data. So very common are different kind of gaps in the data. Example here is Estonia. The area marked with yellow on the map had a severe storm that affected the mobile network as well. And the consequence was that for that area for a couple of days, there are actually no data available. But it can also happen that when we think about this mobile phone data pipeline, then moving data from one stage to the next one, there can be some technical issues. So some data will be left behind. So there can be like many different reasons for that. In addition, there can be that the cell locations have wrong location information. Also, maybe something went wrong with the time zone conversion, so your data gets shifted by several hours. The list goes on, and yeah, this here is not the final list. So now, when we think we have this pretty big challenge, we need to detect all the issues. More importantly, we want to be able to say that everything is okay with our input data and we can continue on with our data analysis. So how to tackle this? Here, you need to start with the basics. First, check the file size. Is it what you're expecting for? Then move on to the attributes. Are they all present? Are they formatted correctly? Then you can start looking at this temporal and the spatial level of the data. And the final step would be the most complex part, where you are looking at the context, like does the data make sense in real world? Example here would be how to distinguish if the data records are generated by machines that also often might appear in the mobile phone data compared to humans. Now you have to make things also measurable. For that, we can use specific checks or indicators. We can classify these into two, as their names also say. First, we have the syntactic checks. These focus on data format, also data structure. So these are covering the record level issues we spoke like a couple of slides ago. And then we have this second type. These are the semantic checks, and these are the ones that are looking for the logic and also meaning in the data. Now, more specifically about these checks or indicators we are looking. From the syntactic side, we're looking at the data files. We are looking for invalid records. So how many rows are not usable for us and have some issues. Then more specifically on the column level as well, like which column is the source of the issues. Then we're also looking for duplicate rows in the data. But in addition to that, we're also comparing our cells reference data with our events files, because we want to see if all the cells that are attached to our events also have actual cell location information attached to them as well. And then from the semantic checks side, as also mentioned, start with the temporal patterns. Can look at the record, a unique subscriber, and cell location distribution, like how hourly level, daily level, weekly level, monthly level. So we're looking at the journal or these 24-hour patterns and also daily, weekly, and seasonal patterns in the data. So do these make sense? Then also looking at the spatial distribution of the same cells, records, and users. So what we expect is that the areas that have more dense population also have more cell towers, more users, more records. Then we're also looking at the subscriber presence. So for example, if we have 1 month of domestic data, for domestic users, we expect them to be present in the data for almost the whole data period, compared to, for example, if we have inbound data, then we expect the presence to be somewhere around the length of an average tourism trip. Then we can look at the time between subsequent records, also the daily record count for subscribers, and also this different kind of duplicates where we don't want to see user being in two places at the same time as well. So another challenge we face when working with empathy data is that it might include also records from sources that are not part of our population of interest. I already mentioned that some of the Internet of Things devices might also use SIM cards. Examples here would be security cameras, GPS devices, some smart gates, or similar. But there can be also this kind of human activities that are affecting our data. So, for example, people who have their phones turned on while they're in airplanes flying, also people who are on the ships passing by the country, connecting to the coastal antennas, but actually never entering the country themselves. similar thing happening on the land border as well, where somebody from another country can actually accidentally connect to this other country's cell tower without ever entering the country themselves. And how to tackle this is to implement smart data filters. Yeah, and we need to use these more specific spatiotemporal patterns to analyze the data. One more topic before we go to the notebook exercise is this automation versus non-automation in the data cleaning process. So because mobile phone data is a very large data set, it is very important to use this automation. So you can create your systems in a way that it automatically detects and also fixes some of the issues. The easy example here would be dropping the duplicate rows. You can also create the system in a way that it automatically terminates the process when some specific threshold value is exceeded. But sometimes, yeah, the issues are more complex, ambiguous, they're not so common. So in those cases, you also need human intervention. This was a quick overview of the theoretical part. You can see it also in more detail from the video on the course webpage. I'll just now We'll move on with the notebook just to show you that from the course page, I'm talking about this interactive notebook activity that's under the 5th session titled Input Data and Quality Assurance. So when you press on the link, this Google Colab notebook will open. For today's session, if you want, you can try to follow along, but I think it's totally fine if you just look what I'm doing, and then later on you can open the notebook and try it out on your own. One thing to point out that when you work with these Colab notebooks, use this copy to your drive option, since then you can create a copy of this notebook. And you can also save the changes, because after you close this one, all the changes you did will also be lost. Yeah, so moving on with this exercise, there's 3 topics this notebook is covering. First, the record level syntactic checks, then semantic checks, and then also contextual filtering topic. Each part of this notebook has this pre-written code. There will be a quality report example, then you can interpret on your own. And there's also going to be a small independent exercise attached to this. This notebook will not cover all the aspects of the QA, because otherwise it would be a very long notebook. But the idea and the goal here would be just to try to give you an idea how to do things, how things should work, and how you can work with these MPD data sets. And for this notebook, we have synthetic data that we're using. So this is not real MPD data. And we have 2 files. We have our events and we have our cell location file as well. So as with each Python code, we first load necessary libraries. Yeah. Then we import our events dataset. This is already, it's coming through this link from the FlowMinder GitHub. So here you don't have to worry about accessing or doing anything with the input data. And now when we look at the data, then we can see that we have the column for the user ID, we have the cell ID, and we also have the timestamp column here in our input data. Here, just a little overview of the data set. We see that we have more than 4,000 rows. We have more than 1,000 unique users in the data. There's more than 4,000 unique cell IDs, and the data extends from the 1st of March 2025 to 31st of March 2025. So we have 1 month's data set here. Now, same thing with the cells data. We'll read the cells CSV file. And here we have the cell ID and also longitude and latitude coordinates for the cells. So this cell ID can be then later on mapped back to the events data set with this cell ID column as well. And for the cells data set as well, a little overview. We have 5,000 rows, 5,000 unique cell IDs, and 4,913 unique locations for those cells. That's totally fine, but because it's very common that there's in the same location, there are several cells. Now, let's also have a look at the cells data on a map to add more context to our data set. If we zoom out here a bit, we can see that, yeah, our data and our cells are actually located in Brazil. So this was the overview of the input data sets. Let's now move on to the exercise part. So first, as promised, record level syntactic checks. We are looking for duplicate records in the data, and we are also looking for missing values in the data. So to get started, we first define our key columns in the data, and then we will create a function that will handle dropping these duplicates, finding and dropping these duplicates in our events data set. So we can see that as an input parameter for our function, we have our events data frame and also the list of columns we want to be checked. So you have very basic or simple code here. We will get this deduplicated data frame when we just apply this drop duplicates function here. And in addition, we will also tell this function to return us little statistics about this check. Yeah, this next cell is just applying this function. And as I said, now I'm on this 12th cell here. As I said, that when you do quality assurance, it's also a good idea to use some automation. For that, you need to set some thresholds. So here I'm defining that for me in this data set, it's acceptable if the percentage of duplicate rows is up to 5%. Now we next create another function that takes as an input the statistics that we created with the previous function and also this threshold value that I just defined. I'm not going to go through this code line by line because I think there's also plenty of AI tools that help you understand the specifics very well. But basically, when we now use this quality report function, we give this event duplication statistics as an input. We give this threshold value also another input parameter. We get this data quality report where we can see that for our indicator that is duplicate row count, there is 82,860 rows that were duplicates. Our threshold value, as said, was 5%, and the percentage of erroneous rows is 1.93, so less than the threshold value, and we can say that this QA check is passed. Now, similarly, once we have removed the duplicate rows, we will be looking for values any missing values in the data. So for this, again, we are defining another function. Again, we need a data frame as an input and also list for the column names from which we are interested in looking at the missing values from. And basically what this function does, I guess the key here is this looping place where it goes through each of these columns in the data frame and looks for any missing values there. Now, again, if I apply this function here to our already deduplicated data frame, I get three outputs. I get the cleaned data set. I get another data set that includes the any data that had any missing values, and also similarly some statistics about these values. This here is just to show you that everything worked well. We did catch some rows that had data issues. For example, this first row here shows that the user ID and the cell ID both were missing, although the timestamp is present. For the second row, the cell ID is missing. But again, for us, this row is actually not usable. And similarly to this deduplication here, I'm again defining what would be my threshold value for acceptable error count or error share from total records. And now we can use the same quality report function once more that we already created. And here we can see that from our total row count, we had 0.08% of these rows that had some kind of issues. More specifically, there were 0.05% of the rows where the user ID was missing, and also 0.08% of the rows where the cell ID was missing. So you can see that, for example, for this, if we look, the total rows with issues, then all of these rows had issues with the cell ID. For some, the user ID was present, but for the 0.05%, the user ID was also missing. But since all of these percentages are lower as our allowed threshold value, then actually in summary, all the checks are passed. So now your, can say, homework exercise would be that with this previous step, we worked on events dataset. Then the task would be to do the same thing with cells dataset as well. These comments here will help you get started. The idea is that you can use the same functions that was used for events dataset as well. So this drop and count duplicates function here, also the quality report function, and then also drop and count missing values function as well. And again, the quality report function here. So the task would be try to fill in the blanks, mainly with the correct or like suitable naming, defining the columns, and then you will get similar quality reports as well that you can then go through. So this was example of the syntactic checks you can do. Now moving on to the next class, these semantic checks in the data. We will be looking at two things here. So first, the daily event count. So we want to see a time series that will show us the number of events for each day. And then we will also be looking at the map view. We want to see the event and unique subscriber counts across cell locations. And the input for this step would be the already cleaned data that we generated from the previous step. So let's start with these daily event counts. Again, we'll create a function where we aggregate our data to this day level. We count the record counts for each of these days. And here I've just displayed the final event statistics. So just by looking at these results, we can see that in general, everything seems fine. The only thing that stands out is the very last day in this data set. That is the 31st of March. But since we know that this is actually also the end of the data set, we can say that this is actually acceptable for our case. And now also best to see everything visually as well. The same daily event count shown on a graph. One thing we can see from here is that on the weekends, here and here as well, the daily event count is lower, what is also expected from mobile phone data because people are less active during the weekends usually. And more active during the weekdays then. Again, here we also want to implement some automatic checks. One option to do that would be to use the standard deviations. So here I'm defining that the acceptable standard deviation threshold would be 2. So now I need to create another function that takes as an input this data frame with these daily statistics that we just looked at. Then also will tell that use the event count column name where we have the daily event counts and also the number of standard deviations to use as a threshold. So the default here is 2, but actually you can change it on your own. And now we get another quality report here that tells us that the average daily record count for these periods was somewhere around 135,000 events. The standard deviation somewhere around 26,000. And this is the range for the standard deviation. This is how many days was analyzed. This is how many days with anomalies were found. And a bit more specifically, if it was a peak or a drop. So we can see that there was this one drop. And very useful thing is also to print out or list out days with issues. This we already know is the very last day of the data period where we are expecting less events. Here can be a bit like careful as well, because very often these outliers can also apply to something actually valuable in the data, because sometimes, for example, there can be some big events. There can be some events, and also holidays are the ones that usually affect these outliers the most. But that's something to take into consideration. Also, now visualizing this same thing, always good to have a visual overview as well. But yeah, basically this is the green will be our period average, and then the red and orange the threshold values. And the second thing, looking at the events share in cells. So if in the previous steps we aggregated on the day level, so now we aggregate on the cell location level. And if we now have a look at these results on a map, the same cell locations as we looked at when we imported the cells, here the bubble size shows us the proportion of the total events in the cell, and then the bubble color shows us the share of unique users in this location. And tied to this is actually the next exercise as well. So by looking at these data sets, the question would be to say if the events and users are logically distributed, mainly focusing on the distribution between urban and rural areas. Yeah, one thing to keep in mind with this data set is it is syntactic. Sorry. Yeah, so this is not synthetic, so it's not real empathy data set. So it might be not following the human patterns exactly, but in general should be okay. And another question is that what potential issues might you suspect if you, for example, see a very large bubble, meaning very many events and users in very remote or rural areas? So my experience is that I've seen that kind of cases, and the reason for that was actually a factory that had very many devices also using these SIM cards for their work. So those needed to be removed. And now we've reached to the last part of this notebook, the third and most complex part, the contextual data filtering. And in this notebook, we will be then trying to detect IoT devices from our data set. And as an example, let's consider that we have this device with this ID. It's always reporting from this one cell location. What is the warehouse location? And let's say that our device is a temperature sensor in a warehouse. It's reporting very regularly after every 60 minutes. And yeah, this is our sample timeline. So it's reporting at 9 o'clock, then a minute past 10 o'clock, then again 11 o'clock, and so on. So for this example device, we know that it's very static. It's in this one location. And it's also very regular. Not always, but mostly the interval is somewhere around 60 minutes. As a comparison, we also have this human user who is visiting many different locations, for example, home, work, shop, etc., and is reporting with very irregular intervals as well. And now, how to detect these IoT devices? We are trying to create a function that is looking at these behavioral patterns. So our basis on is that we are looking at this interval pattern dominance and also the static location. So for us, the key concept here would be that the IoT devices have a dominant reporting interval, and they are also very static. And human users are the ones that have irregular patterns and are also moving around a lot. Yeah, the arguments that we're using for our function is our events data frame with all the columns. Also, we will define the minimum number of events that every user needs to have at least, because for some human users who are not that active, they might have only a couple of events in the data set, and then already their interval the regular intervals get very high. And then we also defined the dominant interval percentage, also allowed maximum location counts, and what is the interval tolerance, because with this example, we also saw that the reporting is in fact happening exactly in every 60 minutes. So if we say that we allow this fluctuation for, let's say, 5 minutes, then that's also acceptable. And now if I run this function, I have my IoT device candidates. And from these candidates, I can see that, yes, all of these are present in only one location. They have this very popular interval in minutes. And this interval is happening for more than, the first one's like more than 80% of the times. For our case, we can say, yes, this is potentially an IoT device. And again, I will define this threshold value by saying that I accept 5% of all my users to be IoT devices. And when I run this threshold value on my data set where I've labeled some of the users as potential IoT devices, then I can see that the 4.76% of these are IoT devices, but this is lower than my accepted threshold value. Below here, there's a couple of functions for visualizing these results. I'm not going to go through them at this point because I want to leave some time for the questions part as well. But yes, this was the overview of the notebook, how you can go and do some syntactic checks, then semantic checks, and also some contextual data filtering as well. And as well, look at the data quality reports.
Fantastic.
Kathy?
Thank you so much, Egla. Thank you very much for giving us a run through of the notebook.
Yes.
Are you done? Oh, got two of you now. Oh, hi. Are you finished?
I'm finished. Yeah, ready for questions.
Great. So, folks, do please feel free to enter any questions you want to enter into the chat. And I will begin with one, which is about reflecting on your Internet of Things section there, Egla. Do you recommend removing the Internet of Things devices, or if you've set a threshold and the threshold hasn't been exceeded, would you just leave them in?
I would for sure remove them. The threshold value is actually more to tell us that, okay, we found like this couple of percent of users that are potentially machines. They most probably are going to start affecting our final results, and let's just get rid of them. But if we can see that the percentage of these IoT devices gets very high, then that's actually like indicator for us, for number one, to talk with the data provider, maybe, but also maybe there's something wrong with from our side with our data filtering, because we don't want to like just remove, let's say, 10 to 20% of the users that actually can be very valuable for us.
That's helpful. Thank you. And then another question in the example with the synthetic data, there was a drop off at the end, which, okay, might
Mhm.
be to do with the parameters set for obtaining the
Mhm.
data. Let's imagine that drop off comes in the middle of the data set time period, in the middle of the time series. What's your recommendation for colleagues who are analyzing this type of data and see one or two or more significant drops that they can't explain through something like a pattern of movement that's associated with, I don't know, people leaving the place, like we sometimes saw during COVID, for instance? What would you do? You mentioned the data provider just now. Would you be recommending going back to the data provider, or how would you handle those big drops?
Yes, I would recommend to go back, ask for explanations because I'm in based on my experience, sometimes they say, "Oh, yeah, we just had a little like technical issue. Actually, the data exists. We can actually give you the data." Sometimes they say that, "Okay, sorry, there's no way we can actually give you the data. It just doesn't exist, right?" So then that's also very valuable knowledge for you because then you can take that as an input for your data analysis. And once you're like interpreting your results, you know that if there's something you can see from the results, it might be affected because of that data gap as
Okay,
well.
thank you. Thanks. I hope that answered that particular question I got. And then possibly another question could be, do you have particular indicators for quality assurance that you really would prioritize over other ones? You've run through some at the moment in the session, but are there any particular indicators that are must-haves that you'd highly recommend or prioritize over others?
So I would say, as I went over in the theoretical part as well, that it's a smart approach to start with the basic ones, the easy ones, the file size that already very quickly is telling you that there's potentially something wrong. Also, like this daily user count, event count very quickly gives you an overview that, okay, I can move on and spend time on more complex analysis. Yeah, these are actually like this pretty fast and often very, so in some cases, even yeah, everything you need to already see that there is some like issue there.
Great, thank you. That's really helpful. I think you can stop sharing your screen now, Igle. Thank you so much. Are there any other questions? I'll give a couple more seconds to anybody on the line who would like to raise a question. And in the meantime, I will also have my own hosting question to the participants who joined us today. And then I also want to remind people that this was the first of 5 training sessions. And the next one is going to be same time, same day next week. And it's going to be on the topic of continuity models. So we'll have another trainer talking to us about how you understand the concept of continuity models and why they're important in the analysis of mobile phone data. So do come along and join us for that. The format will be similar in as much as we'll go over in short order the theory, and then we'll be spending some time actually looking at the notebook and the practical application that you can use this kind of approach in your data analysis as a technical person. Okay, I don't see any other requests for questions to be handled. So I will also take the opportunity to remind people there are discussion forums available on the Data Academy where you can post a question to your peer group, and also it'll be flagged to the relevant instructors who can provide guidance. So do also use that as an opportunity to interact with the training team and get some feedback or get a question answered. Without further ado, I will say thanks very much for joining. Thank you for presenting, Igla. and
Thank
we'll
you.
see you in other calls. Thanks, everybody. Bye now.